If you have been solving problems on Leetcode for a while, you must have come across this very famous Leetcode problem known as house robber, where you are given n houses with some valuable items placed inside of it, and you are a burglar who is trying to rob some of the houses. But if you decide to rob the ith house, then you cannot rob either the left neighbor or the right neighbor. And your goal is to get the maximum value after robbing a subset of the houses such that you never rob two consecutive houses. Now, this is the most famous dynamic programming problem for beginners to Leetcode, and most likely you have already solved this problem before. But if you are into competitive programming and if you have heard of Codeforces before, then there is also a harder version of this problem where you want to find out, given a particular subarray L to R, suppose you have multiple queries and in each query I give you two integers L to R, and you have to answer this same problem but not on the entire array but on the subarray that is created from this segment from L to R. So in this video, we'll look at some techniques to solve this harder version of this problem. And of course, I don't expect anyone in an interview setting to ask you the harder version of this problem since it involves a bit advanced concepts. However, if you love competitive programming and if you have experience with Codeforces, you will appreciate the things that we discuss in this video, because the solution idea is very novel, even though you might not be able to reuse it for future problems. So watch this video just for fun, not for trying to learn something or trying to implement the harder version. So as a refresher, let's talk about the Leetcode version. How do you solve this Leetcode version in case you are not aware? So this is a very standard dynamic programming problem where you define a 2D DP where DP of I comma j, and this j can either be 0 or it can be 1. So 0 means you have skipped the house and 1 means that you have robbed the ith house. So with this DP definition, so the DP definition is DP of ij denotes what is the answer for the ith prefix. You want to rob the houses from the first I elements such that the decision that you made at the ith house is robbing it if j is equal to 0 or skipping it if j is robbing it if j is equal to 1 but skipping it if j is equal to 0. Now let's quickly write down the DP transitions. So first you decide to rob the ith house. So that would mean DP of I comma 1. So if you decide to rob the ith house, how much value would you get? So robbing the ith house will give you this much profit. But then if you decide to rob the ith house, you cannot rob this left neighbor. So you have to take the contribution from DP of I minus 1 and you have to necessarily skip the ith house, I minus 1th house. And what about DP of I0? So if you decide to skip the ith house, does it mean that you have to rob this I minus 1th house? Not really, because it's possible that you have an infinity over here, and if you decide to be greedy and then rob it over here, then you might lose the valuable items from here. So this would simply be max of, we don't care what happens to the left neighbor. So you either decide to rob it or you decide to leave it. DP of I minus 1, 1. And then you can see that since DPI only depends on the values of DP of I minus 1, so you maintain this DP when going from left to right, and that's how you solve the problem in O of n. And in the Leetcode discuss section, you will see that a lot of people claim that you don't really need DP tables and whatnot, and you can just maintain two quantities like best skipped and best taken. And that is all right, because these versions, they actually stem from the DP idea only. That is, if you want to space optimize this DP, you can notice that you don't really need the entire DP row. You only need to keep track of two variables: what is the best profit so far when you have skipped the last house, and what is the best profit so far when you have taken the last house. But then you will notice that to compute this DP transition, you actually have to iterate over this entire thing, and there is no easy way to optimize it. Like if I want you to do the answer from L to R, you cannot simply say, just like prefix sum, you can't say that the answer from L to R would simply be compute this entire DP and then uh, compute this DP and then subtract it. That doesn't work. So you do have to do the traversal manually. But is there a way to avoid doing the traversal and then do the DP computation faster? So to look at that, first we need to diverge a bit, and first we need to talk about Fibonacci numbers, because that will form the base of what we are trying to achieve. So for Fibonacci numbers, let me write that down. Again, if you're coming from Leetcode, then you might know that Fibonacci numbers can be calculated in O of n using dynamic programming. And this is again one of the most standard DP problems on Leetcode. But if you're coming from Codeforces, you will know that it can be computed even faster, which is in O of log n, using some advanced tricks from the dynamic programming world. And how do you do that? I mean, it's not really advanced if you have taken a linear algebra course, but I'll show you. So you have this definition: f of n is equal to f of n minus 1 plus f of n minus 2. So here you see that if you have the last two values, you can get the next value. Now we'll apply some linear algebra tricks, and there's not really a lot of intuition behind it. Like, we are doing things in a smart way, and once we reach some goal with it, you'll see why we did some rearrangement. So these kind of tricks are very common in linear algebra. So I'll do some fancy tricks like so. So you have written this f of n as this, and I'll write one equation that is always true, which is f of n minus 1 is equal to f of n minus 1. Now you have two equations and you have three variables. Now you know that solving a system of equations, that can be done via matrix and determinants. But can you write this down as a matrix instead of having to deal with two equations? So if you were to write it as a matrix, what would that look like? So you would have f of n over here, you would have f of n minus 1 over here, and you can see that on the right hand side. So this is a 2 cross 1 array, right? So this is a 2 cross 1. So on the right hand side, you would need something, let's say 2 cross 2 into 2 cross 1, so that the final product is 2 cross 1. So, okay, we are looking for such a matrix, let's say A, B, C, and D. And the variables are this: f of n minus 1, f of n minus 2. Right now, we are not even sure that such a matrix exists, but we are trying to see if such a matrix does exist. Now, how do you find out this? So you see that when you do the matrix multiplication, you would have something like A into f of n minus 1 plus B into f of n minus 2. This will be the topmost element of the matrix after you have multiplied this row with this column. But this has to be equal to this, the number that you are seeing on the right hand side, f of n minus 1 plus f of n minus 2. And similarly, when you do this computation, you would get C into f of n minus 1 plus D into f of n minus 2 is equal to f of n minus 1. Now, if you can choose this A, B, C, and D very smartly, then you can satisfy these constraints. So what can you choose? You see that A and B and f of n minus 1 and f of n minus 2 are appearing on the right hand side. So A and B, if you choose as 1 comma 1, you are good. And C and D, so on right hand side only f of n minus 1 is appearing and D is missing. So if you choose C as 1 and D as 0, then you would satisfy this equation. It means that you don't have to carry the baggage of writing two equations all the time. You could just write one equation like so. So with Fibonacci, you can write a single equation which goes like this: f of n minus 1 is equal to this matrix 1 1 1 and 0, right? This is the matrix that we discussed, into f of n minus 1 f of n minus 2. Now how does this help us? Because this is just rewriting things in a fancy matrix way, but how does it help us? So let's call this matrix as A, and notice what are the rows of the matrix. So the rows of the matrix are f of n followed by f of n minus 1. This means that here it is also the same pattern: f of n minus 2, n minus 1 followed by f of n minus 2. This means that if you have f of 0 and f of 1, if you multiply it by a, you would get f of 1 and you would get, sorry, it should be something like this. If you had this quantity a, if you had f of 1 and f of 0, and if you multiplied it by a, you would get f of 2 and f of 1, right? So this number f of n minus 1 appears over here and here. Now what if you wanted to find this f of 3 and f of 2? You can see that this is nothing but a times, again if you apply the uh, same formula, then it would become 2 and 1. But what is this f of 2 and 1? This is nothing but a into f of 1 f of 0. This means that all you need to get started is the starting element, and then it is just matrix multiplication. This means that Fibonacci of n and n minus 1 is nothing but matrix multiplication a several times, and you multiply it by f of 1 and f of 0. How many times this would be? This would either be n or n minus 1. Like, we'll take care of that off by one error. Not a big deal. But the idea that I want to convey is that this is multiplication of several matrices which are identical. Now, one thing you will know about matrix multiplication, and this is where some of your linear algebra knowledge will come in helpful, that they are associative. And by that I mean you can replace the brackets around. So AB into C is equal to A times BC. So that's why even though the brackets existed like so, this and this, you could actually replace all the brackets so that the brackets exist like so, this followed by this. This means that if you can quickly compute, so this matrix A remains a constant, right? This is a constant. So if you can quickly compute a to the power n, then you can compute Fibonacci numbers faster. So if you can compute an exponential of a matrix, then you are done. But how do you do this? Again, if you are coming from Codeforces world, how do you compute? Forget metrics. Like if I give you any number x to the power n and I ask you to compute it, how do you compute it? So if you're coming from Leetcode, you might say that it is simply x into x into x into x n times. So the time complexity is O of n. But if you have been on Codeforces, then you would know that you can apply a very simple recursion or divide and conquer approach. So if you want to compute x to the power uh, n, you could simply say that this is nothing but x to the power n by 2 into x to the power n by 2. So if you have a function that that multiplies it, so if you have a function that takes n and multiplies it n times, you could simply call multiplication of x and n by 2. You recursively call this function, you define this as h, and then you return h into h. Now this looks like a very simple transformation on the face of it, but how does this actually change the time complexity? So from your data structures class, you will know that the time complexity becomes t of n is equal to 2 times, no, not really 2 times, it's just one time, right? You're one time only calling. So t of n is equal to t of n by 2 plus O of 1, and this is log n. So this means that using binary exponentiation, you can compute a to the power n if x is an integer in O of log n. But all the arguments that we have made so far, they are not special for integers. So in fact, even if you have matrices, why can't you compute the power of matrices in log n using the same trick? Actually, you can. You just have to call this function with a comma n by 2, because your function is generic. So you call this with a comma n by 2. And while merging the result, all you have to do is you have to figure out how do you multiply two cross 2 matrices. And that is very simple. So in this manner, you can compute a to the power n in O of log n. This means that Fibonacci numbers can actually be computed in O of log n. So okay, this is good, but then how do we apply the same trick to the house robber problem? Because this is the goal of this video. So to do that, we'll have to apply the same linear algebra tricks to convert this to a matrix. But then it is not at all obvious how would you convert it to a matrix. So let's try to be creative and come up with some ways to convert this into a matrix. So let me copy this part over here. Again, let me actually write down the DP definition very clearly, because that will be crucial in determining what is the transformation. So DP of I0 is max of DP of I minus 1, 0, and DP of I minus 1, 1. And then you have DP of I1 is equal to A of I plus DP of I minus 1, 0. And let me remove this part. Now remember, your goal is to write down the DP transitions in such a way that you have a matrix and then you have a product. So, but how do you do this? Like there is max and then there is plus. So we'll apply the same trick. Like you assume some matrix element A, B, C, and D, and then you figure out what should you pick the values for A, B, C, and D. So on the left hand side, like let's say you have this, or let's first simplify it like so. Let's consider this dp of I minus 1 as x and y. Let's see what happens. So this is x is dp of I minus 1 0, I minus 1 0. Then when you do the transitions, if you decide to leave this element, then this is nothing but max of x comma y, max of x comma y when you decide to skip. And when you decide to rob, it is nothing but ai plus dp of I minus 1 0 is what? X. So let's forget this dp definition going forward, and let's keep this very simple transitions, which is x and y. If you have x and y on the left hand side, you want max of x comma y and ai plus x on the right hand side. But how do you achieve this? So let's say you are dealing with this x comma y, and this time let me write it like so. This is 1 cross 2. So if this is 1 cross 2, then you need what do you need on the right hand side? You need a okay, so on the right hand side you need either 1 cross 2 into 2 cross 1, or if we define it in a vertical order, we'll need something else. So okay, let's say if we define it in a vertical order like so. So this is xy, and then this is max xy, and this is ai plus x. Then you are looking for a matrix that you could multiply, so that this is a, b, c and d. Sorry, you are looking for a matrix that you could multiply to this and achieve this. So let's write that down explicitly over here. We are looking for a matrix, let's say that is a, b, c and d, and you want to take x comma y and you want to multiply that such that the results that you receive on the right hand side are max of x comma y and ai plus x. This is the result that you want. But how do you get this? So let's say if you look at this, so this is nothing but a into x plus b into y is equal to max of x comma y. And then you have c into x plus d into y is equal to ai plus x. Now, can you find out a and b that satisfy this equation? At first, it sounds impossible to come up with such a and b, right? Because on the right hand side, you see max and plus and whatnot. But on the left side, it's just dot and plus. Now, this is where some advanced concept will be required from the linear algebra world. Because if you are familiar with linear algebra, you know that this matrix multiplication, this is defined on a ring where you have plus and dot. This means that this plus doesn't literally mean plus, and this dot doesn't literally mean dot. These are just binary operations that are defined on a ring. This means that in fact, you are not just allowed to choose any a and b, you are allowed to choose the binary operations that you want to do which is plus, as well as this dot. So can you choose them smartly so that can you come up with A, B, C, D, dot and plus so that this equation is satisfied? Now, how would you choose your dots and your plus so that this equation is satisfied? So you see that if you choose plus as plus, you can never have this quantity, because on the right hand side you don't have x plus y. So if you be smart about it and you choose something like this, so you need dot and you need plus, right? So let's define this quantity. Let's define p plus q. Let's say that this means minimum of p comma, sorry, maximum of p comma q, because plus can represent anything. So let's say that this means maximum of p comma q, and let's say that p dot q would mean p plus q. So we are switching things around. We are saying that dot actually means plus and plus actually means min, max. So if that is the case, then let's rewrite this equation and see what happens. So this is a dot x. Let's focus here. So this is a dot x. This means plus means max. So this would convert to max of a dot x. A dot x means a plus x, comma b plus y is equal to max of x plus y. And similarly c dot x, and this plus means max. So this is max of c dot x means c plus x in our world. So c plus x, comma d plus y is equal to a of I plus x. So this would mean, so one correction over here, this is max of x comma y. So now can you figure out what should you pick as your A, B, C and D so that this equation is always satisfied? So you can notice that max of, on the left hand side you have a plus x and b plus y, but you need x plus y. So if you pick something like this, a as 0 and b as 0, and then on here you have ai plus x. So if you choose c as a of I and you want this to be the maximum, so this should always be the minimum so that this always wins. So if you set d as minus infinity, then you are done. So now let's take this matrix, let's call it as A, and let's see if it actually gives us the results that we want. So we have this matrix which is 0, 0, A of I, comma, minus infinity. And let's multiply this with x and y, and let's see that we really get this max xy and ai plus x. But while multiplying, make sure that multiplication is now addition, and addition is now maxima. So 0 plus x is x, and 0 plus, sorry, 0 dot, so just so that we aren't confused, I'll write it down explicitly like so: 0 dot x plus 0 dot y, and plus basically means max of 0 dot x, comma 0 dot y. And in our world, dot means a plus, so that's why I will write it in a different color. So this is 0 plus x and 0 plus y, which is max of x comma y, which is what we wanted in the first part, which is what we got, right? So this part is good. A and B we have selected correctly. And what about this case? So this would become AI into X plus minus infinity dot Y. So in our world, it is what? Plus is max, and then max of AI dot X comma minus infinity dot Y. And then in our world, dot is actually plus. So this is max of AI plus X, and this is minus infinity plus Y. And of course, since this is the minus infinity, you can assume that this will always win, and this becomes AI plus X, right? So you can take out this max term over here because this you have smartly chosen as minus infinity. Now you will notice that this max, so we wanted to find this plus and dot, but we have chosen this max and plus. Dot means plus and plus means max. So this is your max semi-ring on the matrices. Why is it a semi-ring? Because every element does not have an inverse, because unique inverse. So if you see, if I tell you that max of x comma y is equal to x, uh, can you find a unique y? No, because there can be a lot of y. But if I tell you something like this, if x plus y is equal to x in our normal world, then you know that there is a unique identity element, or sorry, there is a unique inverse called minus x that can produce this 0 over here. If I tell you that x plus y is equal to 0, which is the identity element. Similarly, here the identity element is like, let's say, minus infinity. So if I tell you that max of x comma y is minus infinity, there could be a lot of things that could satisfy it. So all that aside, you can see that our transitions can now simply be written as, for any AI, you define this capital A as 0, 0, AI and minus infinity. Then you can see that when you are doing the transitions, if you have the dp value of the initial state, which is x comma y, all you have to do is multiply these matrices. So the answer would be simply, if you are dealing with this array, if you are dealing with this array, then to compute the dp value of this entire thing, your answer is simply a1 into a2 into a3 into a4 up till an, and then this is simply x y, and x y's are the starting point of the recurrence, which is the dp value of the first house in isolation. So dp value of the first house would be 0 if you don't rob it, and a of 0 if you do decide to rob it. So you can see that to quickly answer the problem for any subarray, you have to do n matrix multiplication, but these matrices are already predetermined, 0, 0, ai and minus infinity. So how do you actually do matrix multiplication? So see, the main problem with rings and semi-rings is that these matrices are not invertible. So they are not invertible, because had they been invertible, all you are looking for is the product of matrices in this section. So you could have computed the prefix product. You could have computed the prefix product. And then when I ask you to solve it for L to R, you could get this entire thing, and then divide it. Only problem is that matrices cannot be divided because they might not have an inverse. So this is where your standard techniques will come into picture. So if you have n integers, let's say a1, a2, a3, a4, A5, etc. And if I quickly ask you to find the product, and product basically means A2 dot A3 dot A4. But I tell you that this dot doesn't actually mean the product in the normal sense, because in the matrix multiplication also you saw that dot didn't literally mean multiplication. It just meant an operation. So how do you do this? So to do this, you can simply use, there are multiple ways to do this. So first approach is to use divide and conquer. That is, if I ask you to find the product of n matrices up till an, then you divide this range in half, and then you recursively solve for n by 2 on the left hand side and n by 2 on the right hand side, and then you merge them. And how do you merge them? You will get 2 cross 2 as a result over here, because no matter how many matrices you multiply, the result will always be a 2 cross 2 matrix, and you will get a 2 cross 2 matrix over here, and then you multiply them and send the result forward, because 2 cross 2 into 2 cross 2 is also a 2 cross 2 matrix. So this is one divide and conquer strategy that you could do. What is another strategy? Another strategy is that with this divide and conquer, I think if you are just looking for the product, and as long as you can ensure that the inverse existing is not a strict criteria. I'm not sure about the details, but I think they should also be solvable via square root decomposition. That is, you pre-compute the product for each square root of n block, and then when you want the answer for the range L to R, you can only have root n different blocks. So you simply look up the answer from there. And I'm pretty sure that square root decomposition does not require the existence of inverse, but I'll have to double check on this. But the last and the final solution that you could implement is the one from AdCoder. So AdCoder, and this is where you'll appreciate the library that AdCoder has come up with for the segment tree. So for the segment tree library that they have designed, they say that they can give you a product of any range. So you just give it integers of a1, a2, a3. Not really, they don't really have to be integers. You just give it some numbers, or whatever struct that you have. And if you ask it to compute this a3 dot a4 dot a5, it can give you this in guaranteed O of log n, and internally it is just using the divide and conquer approach that we just discussed, right? Like it divides in two segment, and that is basically segment tree. But this approach avoids explicitly writing your own segment tree. So this is O of log n, and at Coders library says that a doesn't have to be integer. This dot doesn't have to be product. You define what is this dot. So for our case, this dot would mean matrix multiplication. And in our case, this A3 would mean a 2 cross 2 matrix. So all you have to do is tell it how do you want to define A dot B. So A dot B, you define what do you actually mean by A dot B. And then you define your identity element, and then you are done. So with AdCoder's segment tree library, you just have to define n matrices, and the ith matrix would be this. Sorry. So you get the idea, right? This would be the ith matrix, 0 0 ai n minus infinity, 0 0 ai and minus infinity. And every time you want to solve for the range L to R, your starting elements would be 0 comma A of L, and then you are looking for product of constant matrices that are predetermined. So you can do that via segment tree, and then once you get that product, you multiply it over here. But when you do this multiplication, remember that this multiplication is on the max plus semi-ring on the matrices. So this is max plus. So once you do that, you will be able to quickly answer the problem for a particular subarray. Not just that, you can now see that once segment tree is in the picture, you can actually modify, you can replace AI by X, and you can actually solve the problem online as well. That is, if the query consisted of two types, one is changing the array elements, and the second query is finding out what is the answer for the house robber problem in a particular subarray from L to R. You can do that by simply via segment tree, because at coder's segment tree, even though it asks you to define these operations, like what does a dot b mean, like how do you want to combine the left half and the right half, it actually internally accommodates the updates as well. So you don't have to worry about the updates, you just keep updating it and you keep asking about the product. So in fact, if you look at the notation of the at coder segment tree library, it contains the word prod, and this prod doesn't literally mean prod of these three elements, product of these three elements. This means dot of all of these three elements, and this dot is any operation that you could define, and this AIs are any operation that you could define. And this is, I believe, one of the best example of demonstrating how useful the atcoder segment tree library is, and how versatile their definition of dot and structs are. So in this manner, you see that you have now solved the original Leetcode problem in O of log n per query. Right. Of course, if you need to solve for the entire array, one single pass is enough. But if you wanted updates, on this array, as well as if you wanted to answer subarray queries, then you could do that via segment tree and matrix multiplication. Now, is matrix multiplication too advanced a concept? I don't necessarily think so, because we are living in 2026 and at coders library is already out. So I don't believe it's advanced at all. But do let me know your thoughts in the comment section. Like, how did you find this problem, and do you have any alternative way to approach this subarray queries for the house robber? Thank you.